And as I had mentioned before, Unit 3 was really kind of the heart of the course with the dosage calculations and all the medical math. 1 and 2 is kind of the lead up to that. Units 4 and 5 are kind of prepping you for the next step. So we saw Unit 4, a little bit of that introduction to college algebra. Most of it's stuff you've probably seen before. Unit 5 is the introduction to the course that every medical related 4-year degree is going to require, and that is statistics. And to be honest, not just every medical related bachelor's degree, but you're looking at probably 75 to 80% of all bachelor's degrees require a statistics course of some kind. And there's a good reason for that. Statistics, it's everywhere around us. The world can be interpreted through statistics. It's what summarizes what's happened and allows us then to predict what can happen. One of the biggest fields in the United States that a lot of people haven't heard about is something called an actuary. It sounds like a weird word, but what it is it's people that use statistics basically to predict the future. Now, it sounds a little more dramatic than it is, but what these are the people that work for an insurance company to predict how many claims are going to be made on a policy so they can figure out what would have to be charged for that policy to make it profitable for the company. That, of course, involves a lot of statistics. The same is true for a lot of government agencies employ actuaries to figure out what type of revenue has to come in to cover the expenses that the institution is going to have. Again, that requires analysis of statistics. So statistics are everywhere, and in order to make sound decisions, a basic understanding of statistics is really necessary. That is why in your large corporations, your CEOs, your chief executive officers, and your CFOs, chief financial officers, the two biggest characteristics that they have, typically, most of them have a background in accounting. In other words, they know how to follow the money, they know how to manage the money, and they have some sort of a background or at least an understanding of statistics. They know how to look at the numbers and make decisions based off of those numbers. Outside of employment, statistics are very important as a consumer because you see them everywhere. Advertisements like 4 out of 5 dentists recommend our White Bright toothpaste or whatever brand name you want to throw on it. Those statistics are everywhere, but unfortunately, most of the statistics thrown at you as a consumer are twisted in such a way as to favor the product they're trying to advertise. You're saying 4 out of 5 dentists recommend our product. Does that mean that all the other products are split between that last one? Well, no. When they say recommend, they say that the dentist looks at it and says, yeah, I'd approve of that, or I would recommend that. That doesn't mean that that's their favorite kind of toothpaste or whatever. Looking at how statistics are gathered, how samples are created, and stuff like that is very important. So the goal of this unit is to give you a little bit of a background for going on to the next step so that when you look at taking a statistics course, you have a little bit of a background to start it. But it's also to help you be a little bit more of an intelligent consumer when it comes to all the statistics that are thrown at us. And we'll look at some of the things that are done to skew statistics as we go through. So today, we're going to look at a lot of vocabulary. Statistics has a lot of words that are unique to its study, and they also have a lot of words that we've heard in other contexts, but have a very specialized meaning within statistics. Most important of those words is a population. Now, often in the medical field, our population is people, but we can do studies where our population is items. It could be parts coming off an assembly line if we're in quality control or whatever. What the population is, it is the group, whether that is people or items or whatever, that we want to learn about. Now, from that population, there are parameters. Parameters are simply information describing the population. Now, there are a lot of parameters that could describe a population. Let's look at an example here and actually show the difficulty in even defining a population. So let's say we're looking at a local election. And let's say that the mayor of your town is up for election. And we want to predict who's going to win that local election. It would be really easy to say, well, the population is all the candidates that are running for the office. Well, yeah, we do want to learn which one's going to win, but that's really not the group that determines what it is we're trying to find out. The group that's going to determine who wins that election, the group that's going to determine who wins the election are the voters, and more specifically, those who will vote in the election. There might be people who are not registered that Wisconsin allows registering the day of as you vote, or there might, a lot of people would mistakenly say registered voters, but there are many registered voters who just don't care and won't vote in the election. So those people that don't vote don't have any part in the decision, so we don't care what they think. We only care about those who will vote. Well, there are a lot of parameters describing that. Of course, they have to be 18 or over. They have to be a resident of the city. They have to be eligible to vote and all of that. But that's not what we want to learn about. Those are parameters. So what we define is something even further called a parameter of interest. What the parameter of interest is when we're doing any sort of statistical action, we are asking a question. In this case, that question is, who do you plan to vote for? So that parameter of interest then describes the answer to that question. So as we said, there's a lot of parameters in the voters who are going to vote in this election. They're 18 or over. They're residents. They are not convicted felons, so they haven't lost their right to vote in any way. But the parameter of interest might be that a majority of people plan to vote for candidate A. So that's the parameter of interest. It's describing our population, but it's also answering the question that we're trying to ask. And then there's something called a census. We actually did this in 2020, just a couple years ago. In fact, the United States does it every 10 years. A census is an attempt to gather information from a population. As I said, the United States attempts to do this every 10 years. We've never been fully successful because you can't get every person in the United States to answer that census, which is really what it's attempting to do, to count every person in the United States and then get information about their ethnicity, their age, and other things that's important to the government providing services for those people. Well, usually we don't actually try to study a full population. We typically use something called a sample. A sample is a subgroup taken from the population. So a subgroup is just a smaller group, and it is chosen from the population so that we can gather information from that smaller group. And in a little bit, we'll talk about why we use a sample rather than the whole population. But for now, let's go through some of the vocabulary related to a sample. Just like we have a parameter describing a population, we have a statistic. Statistics is information describing the sample. Now, just like with the population, there are a lot of statistics about that sample that we don't really care about. Their age, their breakdown of gender, ethnicity, all of that. In this case, we only care about who they're going to vote for. So that's really just like we have a parameter of interest, we have a statistic of interest. It gives us the information that answers the question being asked. And finally, we have a survey. Like the census, the survey is an attempt to gather information from a sample. Now, a survey can be done in several different methods. The two most common is observational. So an observational study or survey, we don't do anything. We just gather information from the people. So this could be what we are typically think of when we think of survey, is where you send out a questionnaire and they answer it, or they call you and ask you the questions over the phone. That's an observational. You haven't done anything other than gather the information. But it could also be more of a clinical setting where you have these people that have a certain illness and you just watch them to see how the illness progresses or whatever. In the medical fields, though, it's more often done as an experiment. And an experiment is when you impose conditions. So this might be taking a group of people that have a given illness, dividing them into two groups, giving one group a medication and the other group no medication, just some sort of placebo. That's imposing conditions, giving them the medication or not giving the medication. Or you could be comparing two medications. One group gets medication A, the other group gets medication B. Again, those are imposed conditions. When doing an experiment, it is pretty important to have something called a control. So this is the group that we compare all the other groups to. It's kind of the neutral group. What would have happened if we didn't impose any condition? So we say no artificial conditions imposed. As we're looking at these things, an important thing to worry about is bias. This is where I said we need to understand things that make statistics inaccurate. Bias is one of the biggest things. Adjusting how we report them is the second biggest one. Bias is anything that systematically excludes part of the population. Or another way of looking at it is anything that would cause a difference between the population parameters and the sample statistics. So this is often in the way that we select our sample. If I randomly choose phone numbers out of a phone book, Well, there's a systematic bias there because people who don't have phones or people who have phone numbers that are not listed in the phone book can't be chosen. So I have systematically excluded that group of voters from my sample. And it's very possible, it's actually very likely that that group of voters who don't have a phone and would probably have similar viewpoints and prescribe to a set of viewpoints that might change the outcomes of what it is we're trying to study. Or it might be in the way we ask a question. We might ask a question in such a way that influences how people answer it. It causes bias. It might just, it's called a self-interest bias, where you ask a question in such a way that if you answer it honestly, it could be harmful to you, or it could make you look bad. So most of these are, educational issues are very common for this, where you ask someone, well, are you in favor of paying a few dollars more in taxes so our kids can have a safer school? Well, people aren't going to say no to that because someone watching them and hears them say, no, I don't want to pay money for my kids to have a better education. You could think negatively because of that. So those are possibilities that introduce bias. So we have to be careful how we select our samples, how we word our questions or design our studies, or how we even go about gathering the information, doing it in private so a person doesn't have their peers looking on as we ask them questions and things like that. So we are looking for an unbiased estimate. And an unbiased estimate, of course, means that our sample statistic is equal or really close to the population parameter. And when we manage to do that, what we have is what is called a representative sample. So the proportion or percent of voters in our sample that are going to vote for candidate A is the same as the percent of voters in the population that are going to vote for candidate A. The difference, if these are different, that creates what we often refer to as sampling error. We have poorly chosen our sample so that the sample is not representative, or we've introduced that bias into that sample. Well, let's get back to that question I promised you. Why use a sample? And of course, the implied rest of that question is instead of a whole population. I can't list all of those reasons here. There's a lot of them. I'm going to list just the top ones here. And of course, the ones that almost always lead up any list like this are the big ones: time and money. Most populations are pretty large. It would take a lot of time to contact, especially if it's dealing with people. Even if it's just a small town like, Clayton, or I grew up in Prairie Farm where there's only 400 to 500 people, that doesn't seem like a lot, but it would take a lot of time to contact all of them because they're going to work different times a day, so they won't be available. You have to try to contact them at different times. Finding their phone number might be difficult. It's going to take a lot of time. And of course, that time equates to money. And of course, other expenses, if you're going to mail out surveys, postage, paper, envelopes, all of that are expenses. And most of the time, we are working on a budget. Next is difficulty in defining a population. So like our example of the local election. Let's say we're voting for a new mayor. Well, if we are 2 weeks before the election, we're trying to predict who's going to win. Like we said, we don't care about all registered voters. We only care about people who are going to vote in that election. Well, there might be several people out there that say, I'm not going to vote, so we wouldn't include them in our population. But between now and the election, something might happen, a news story or some event that gets them fired up, and they decide, I'm going to vote, darn it. And they end up voting even though they didn't think they would. We didn't include them in our population, but they should have been. Or the other way around, somebody who is absolutely sure that they were going to vote, but something comes up on the day of the election, something at work or their car breaks down or whatever, and they don't get there to vote. The next one is changes over time. Now this one sounds similar to number 3, but there's an important difference. Even if we could completely accurately define the population and get a hold of all of them, a true legitimate sample, a survey, is done in an instant. The information would be gathered from every element in that survey instantly, snap of a fingers. Well, in real life, that doesn't happen. It takes time to get a hold of each of them. Even if you have several people working on it, you need to get a hold of each person and gather information from them. Even with a sample, this can be difficult to do quickly. So let's say we've chosen our sample of voters and we're going to do it over 3 evenings, Monday, Tuesday, and Wednesday. So Monday, we call 1/3 of our voters. We get the information from them. Tuesday, we call the next third. But then Tuesday night, something comes out on the evening news that's a huge scandal about one of the candidates. Well, we cannot just go on and call the final 1/3 of our sample, because the conditions have changed. Many of those people we've already surveyed would have, based on the information that just came out, might have changed their decision on who they would vote for. If it's a huge scandal, they might not vote for that candidate anymore. Or they might vote for the candidate based on it, whatever that news is. So we can't have even too large of a sample, because if it takes too long to gather the information from that group, the conditions have changed over time. And it's very important that when we gather information from every item under the same, or at least very close to the same conditions. Now the 5th one here that I'm going to list, and that'll be the last one I list out, but I'm sure you can come up with several others if you thought about it. The 5th one here does not apply, at least hopefully does not apply to people and surveying people. It applies more to manufacturing and engineering. And that is destructive testing. So one of the places I worked, we had parts that were produced that must hold a minimum amount of force. Or what's called stress. So what we would do is we would select a part, we'd put it in a machine, that machine would stretch it until it broke. And then the machine would read how many pounds of force it put on that part before it broke. And then we would compare that number, how much force it took to break the part, the amount of force it needed to hold in application, and we'd decide if that was strong enough to be assured that the part would last. Now, why does it have to be a lot higher? And it does have to be quite a bit higher. The reason is we're not going to test every part. This part needs to be a lot stronger so that we're relatively assured that the other parts, even if they happen to be a little weaker than the one we tested, are still strong enough to hold what they need to in their use. Obviously, if we tested every part, it can't work, because then there'd be no parts left to sell, because testing them breaks them. So we want to test enough parts that we are relatively sure that the other ones are going to hold, but not so many parts that we destroy all of our profit by destroying parts and not being able to sell them. So we brought up the term representative sample. And the representative sample meant that our sample statistics were equal to the population parameters. Well, the problem with this is we don't know the population parameters. If we knew the population parameter, then there's no reason to take a sample, because the reason we're taking the sample and gathering the information is we want to estimate that population parameter. So we never truly know if our sample is representative or not. So what we can do, though, is reduce the chance of sampling error. Make it less likely that our sample is going to have those biases in it. And this is where, if this were a full-blown statistics course, we would take a few weeks studying probability so that we'd look at, those probabilities and how likely it is that the sample is going to be good or bad based on those probabilities. But right now, we're just going to look at basic concepts that decrease that chance of sampling error. One of them is a proper sample size. If I want to figure out who's going to win the next election or how the election is going to go, I can't just go outside and ask the next two people I see and have one of them tell me they're going to vote for candidate A and the other one says they're going to vote for candidate B, and then report, hey, it looks like the population is split 50-50. That is too small of a sample. On the other side of it, we can't take too large of a sample because, like we talked about before, if it takes us too long to gather the data, our conditions aren't uniform. The other big thing is sample selection. How we choose the sample is important. And the term that is often used here is called random sampling. In a random sample, the random means that every item, whether it's a person or a machine part or whatever, in the population has an equal chance or the same chance. What happened there? Let's try that again. Of being selected for the sample. So this means, one, we can't exclude any items of the population. They all have to have a chance of being in the sample, but they all have to have the same chance. They have to be just as likely to be chosen to be in that sample. Well, in statistics, this sounds like a great thing, but in statistics, it's not enough. It's not strong enough. We need something even stronger called a simple random sample. And in a simple random sample, we choose a sample size. And the letter we use to abbreviate the sample size is the letter N. So we choose a sample size. We're going to select N items to be in our sample. A simple random sample is not just random, not just every item in the population has the same chance of being selected, but every possible sample of size N has equal chance of being selected. You might look at that and wonder, well, what is really the difference? Well, when we look at samples, there are several different common methods of sampling that are used. Unfortunately, many of them are done for economic or ease of sampling reasons. In a convenience sample, there is no truly random process. In other words, we take the easy data. So let's say I determine that I need to sample at least 50 people, 50 voters, to get an accurate picture of the election. I cannot just walk out on the street and ask the next 50 people I see. There is no random process there because people that are at work or at least not on the street at that time have no chance of being in that sample. It is not a random process. So it's not even random. The next type of sample we're going to look at is called a cluster sample. Now, these next two, the cluster sample and the stratified sample, are very similar in one way. One is we group the data, or we group the population. I'm going to word that a little bit differently. I'm going to say we divide the population into groups. But the key here is those groups are based on ease of gathering data. And then we select entire groups to sample. Well, what does that mean? Well, like if they wanted to do a survey at your school, rather than picking out random students and then having to go around the school finding those students, what they might do is say, we're going to do the survey at 11 o'clock. And so students are in a specific class at 11 o'clock. So we're just going to randomly select classrooms to go to at that time and survey the students that are in that classroom. It allows you to get a large amount of data with a minimum amount of effort. I get everybody in the classroom rather than having to hunt down individual students. Or if you're doing like a door-to-door survey, you might select a whole city block rather than individual people, so you don't have to run all over the city hunting down individual people. You go to a particular block and just go around that block gathering the information. And then you go to the next block that's been selected. As long as the classes in the school are about the same size, or the number of people living on a city block is about the same size, this is random. However, it is not simply random. SRS stands for simple random sample. It is not a simple random sample because it would not be possible for one student from each class to be in that sample. Either the whole class is in or the whole class is out. So not every possible sample of size n can be in that sample. Well, our second type of sample, called a stratified sample, also divides the population into groups. But now instead of being based on ease of gathering information, it's based on common characteristics. And then we select a proportionate number from each group. So if we're looking at doing a survey in your high school again, we might divide the population of the high school students into freshman, sophomore, junior, senior. Because based on what grade level you're in, you might have different opinions of certain issues. And then we would randomly select a number of people from each grade level. Now the proportionate number comes in if the class groups are all pretty much the same size, we would select the same number from each grade level. But let's say we happen to have a huge class that goes through, and the junior class has twice as many people in it as any of the other classes. Well, then we would select twice as many people from the junior class to be in our sample. So this is a random sample, because every person, every student in the high school would have an equal chance of being selected. However, it is not a simple random sample, because it is not possible to accidentally choose a sample that has all the people from the same grade, or at the very least to accidentally choose a sample that doesn't have anybody from a certain grade. Now you might say, well, that's a bad thing to have everybody from the same class, or not having someone from a certain class. And that's true. It's probably more representative using a stratified sampling technique than it would be just using a plain simple random sampling technique. But most of the strategies used to analyze data in basic statistics require that we have that possibility of taking a bad sample. So the simple random sample actually does leave that possibility open of getting a bad sample. Next is a systematic sample. So a systematic sample, we randomly choose a starting point. And then the system does the rest. What does that mean? Well, choosing students, it doesn't really make much sense to use a systematic sample. But like going back to the manufacturing example, if I wanted to choose parts to test, if I wanted to test at least one in every 100 parts, what I would do is at the beginning of the day, I'd randomly select a number between 1 and 100. And let's say the random number I selected is the number 44. So then what I would do is I would test the 44th part off the line, then the 144th, the 244th, the 344th. What this does is I've tested now one out of every 100 part, but it also spreads them out throughout the day, so I'm consistently testing to make sure that no temperature variation or none of the fixtures get bumped and moved so that something's not being done right. It is random because every part has a 1 in 100 chance of being selected. However, it is not simple random because it's not possible to select 2 parts in a row. So that brings us to the question, what is a simple random sample? Well, the way a simple random sample would work, let's say we're going to survey students out of your high school. We would put all the names in a box or in a hat or whatever. Mix them up, of course, and then draw out n of them, however many we need for our sample. So it is literally the names in a hat or numbers in a hat type of selection. That is a simple random sample. So it's possible that all of the students could be out of the same class, or they could be, none of the students could be in the junior class or whatever. It's possible to have all those bad samples because there is no system in place to stop that possibility. So, like we said, The whole goal of statistics is to estimate or draw conclusions about those population parameters. And there's really two levels that this occurs. One is just to describe the population. Demographic data, basically. You might look at, a certain percentage of the population is female, certain percentage male, or whatever gender identity they choose. Certain percentage of the population has each ethnic background, or certain percentage of the population admits to being associated with a certain political party. It's all that demographic data, age ranges, number of people in age ranges, and all of that. We're looking at describing the population, or at least estimating those population parameters for that. That is where we're going to really stick to for this course, is that descriptive statistics. The next step is called inferential statistics. And in inferential statistics, we're trying to make a decision based on what we estimate the population parameters to be. Trying to decide if someone makes a certain claim, or the standard is that 60% of the population supports candidate A. Do we feel that claim is true, or is there evidence against it? The one thing about statistics that's frustrating for people is there's a lot of gray areas. It's never hard and fast. We didn't prove this, and we gathered a lot of evidence in favor of it, or we gathered a lot of evidence against it. For us, like I said, we're going to stick to the part that is set in stone, that there is always a correct answer for, and that is the descriptive statistics. Just so you guys are aware, Unit 5 test will be coming up here really quick. I mean, we're at the end of the year. We move rather fast here. That will be May 5th, or May 11th. That's a Wednesday. And that'll technically be our last class. May 13th is our graduation day. We technically don't have classes that day. But I will be available if you have any questions you need to ask to finish up the test. Unit 5 test is usually a lot shorter, just so that we don't run into that issue of needing extra time to finish up and going into the next week. I have not received, actually I haven't checked my messages here for the last couple hours, but haven't received your Unit 4 test yet, so hopefully you guys are have those finished up or getting those finished up soon. And also, don't forget to get me your Unit 3 corrections if you have not done that yet. We need to get those into the book for you to help you improve your grades. So with that, I don't do this very often, but there is no homework today, because we all just covered all the background and vocabulary.